Okay, welcome back. So like I said, for this class and, this class and maybe the next couple, I'm willing to answer questions. So somebody came to see me before, just before class to ask me a question, a very specific question about what they're doing in their game. And it may be of interest to some of you. So the question is basically, they're trying to generate a random terrain, and in a 2D game, a terrain is really just a curve of things that go up and down, left to right across the bottom of the screen. And so, what's a good way to do that, maybe, and what are the mechanics of doing that kind of thing? So we can try and actually implement that just with a small sample. So let's say you want to generate a random terrain. And what's this random terrain? Well, it's a sequence of maybe x and y coordinates, or it could be just a sequence of y coordinates and the x are somehow inferred. Let's make this one x and y coordinates. Since it's supposed to be random, we should import the random. And I think the plan for this thing is that it should be a list of of the points in the terrain, and we can think about different ways of doing that. But maybe a sort of nice-ish thing is to say, well, our games are rooted at in these windows of 800, width 800, and height 600. So let's focus on some terrain that varies around location, maybe 550. So that's within 50 pixels of the bottom of the screen. So let's say we'll start at 550, and we'll write all of this as a function that takes a value n, which is how many of these terrain points you want to have. So how fancy do you want it? So we'll start at 550 and do something like terrain is an empty list. And I didn't know this question up until a minute ago, so bear with me while we work through it. Terrain is a list. I would like it to contain n points, so let's just count for I in range n. And we'll say terrain.add a new point, and that point will be, instead of start, we'll call it y. It'll have height y, and its x coordinate will be something like, we want it to start at 0, and so I starts at 0, that's good. And we want it to be, let's say, regular, so in n different chunks. So that would be something like I times the width of our window was 800 divided by n. And we put it at this fixed y coordinate, the current y coordinate. And as we go along in this terrain, well, we'd like the y coordinate to change somehow. So let's say, a really crazy thing to do would be something like, say, the next y coordinate will be some random times 100 plus 500. So it's hard to visualize what this will look like, and we won't actually know without looking at it. So let's actually put this into a game. So we start with an empty game skeleton. We will do something like, say, we just wrote this function for generating a random terrain. At the end of it all, we should return this terrain. And when our game starts, we will generate this terrain. So let's say self.terrain is equal to terrain, I don't know, 100 points. All right, so this isn't going to show us anything exciting yet, but let's make sure that the code compiles at least. Of course it doesn't. Terrain is not defined because this was called random terrain, not terrain. Maybe we can print it. List object contains no attribute add. That's because in Python it's called append. It's in Java that it's called add. You see the fun of programming in more than one programming language at once. So yeah, it looks like something got generated. There it is printed out. What we would like to do is maybe display it in our game. So let's see if we can do that. And for that, we need to know, if we want to do the most basic thing, it's something like pygame draw line. Okay, pygame draw lines. Draw multiple contiguous segments. Draw a sequence of lines on a surface. You give it a list of points, and they'll be connected by what they call a line, which is not mathematically a line. They mean piecewise linear curve that passes through those points, and closed if you would like it to wrap around. So let's try that. It's in our text editor. So in our draw routine, we will say pygame.draw lines. They go on the screen. So that's the surface. They should have a color. Let's make them red. And closed. No, I don't want it closed. And the point list is called self.terrain. The last argument is the width, which I will maybe set to 2 so you can possibly see it better. All right. Any chance this will work? Okay. So there it is. There is a random terrain. To me, it's not a very attractive random terrain because the heights that we're using are basically completely independent of previous heights. Okay. So, but now that we have it and we can draw it, we can play around to try and make something maybe a bit more realistic. So usually the trick for these kinds of things is the way we're doing it now is the heights are completely, each observation is completely random. If you want to smooth things, you can think instead about, well, each observation should maybe be some delta from the previous observation. Maybe it goes up or down based on the previous observation. So right now in our terrain generator, we're just saying you pick a random number between 0 and 100, that's this thing, and then you add 500 to it. That pushes it down by the bottom of the screen. But maybe we could say instead, and we'll have to be careful here, that y, what happens with y is you maybe do something like start at -5, or you subtract 5, and then you add a random number in the range 0 through 10. Let's see what that does. Much smoother, maybe not random enough. If you want to make it a bit more rugged, then maybe you would go minus 20 and a random number in the range 0 through 40. So why do I pick 5 and then a random number in the range 10, or minus 20 and a random number in the range 40? Because I want it on average to stay level. So on average, the random number that I pick will be 20 and it'll stay level. If I pick random numbers that are too big, then the y-coordinates will be increasing, and if I pick numbers that are too small, the y-coordinates will be decreasing, and it'll go one way or the other. This way they stay neutral. So let's see how that looks. That's more rugged, but still better looking than the first try. The one thing to look out for is the terrain actually ran off the bottom of the screen here. So you might want to put some check in where you do something like y is equal to, I don't know, the absolute value of y. No. Let's just make sure we don't completely run off the bottom of the screen. So let's say that it's equal to the minimum of the height of this screen, which is 600, and the min of 600 and y. So it doesn't run off the bottom. There. Something a little more rugged. That one kind of runs up. And if you want, if you're worried, so now there's a danger that it could run really high. If you don't like that, then you can say y is equal to the max of y and some other range that you don't want. So you can keep it trapped in between two things. We'll just show that. So let's say that I never want it to rise above 500, so then it should be the max of 500 and y. Oops. Yeah, so that drives it down a bit too much. Maybe it should be 450 is a better limit. So play with these kinds of parameters and see what you get. And this is just one way to do it. So truly random looks kind of weird. It's all over the place. This kind of thing looks a little bit better. And this is really, again, now what we're basically doing is, if you want to make it look better or smoother or nicer, you're basically doing calculus you're pretending to do calculus in a discrete setting, right? So the first thing was somehow just straight observations. The next thing was actually specifying the curve by specifying the slope of each segment rather than just some random observation. And you can even go, look back a couple of steps and look at the second derivative and whatever you want. But I think you can get something reasonable just by playing around this way. Does that answer your question? Okay. Okay, does anybody else have sort of how-to questions like that? No? Okay. So we'll go back to what we were working on last class, and maybe a couple of things will come up. So let's, this was called asteroids.py. So we were making an asteroids game. This is this game with a ship that starts out in the middle of the screen. You're supposed to be able to drive it. Last class we got to the point of drawing the ship. We even got to the point of implementing some notion of thrust. So the ship has a direction, it has a vector that it's traveling in, it has a rotation that it's rotating at the sort of speed of rotation that it's rotating at each frame, and we were working on what happens when the ship thrusts. and we had a bug, and of course, it's the usual thing. So this is this function. The ship's direction is specified as an angle, and angles are measured in between 0 and 360. Before you can use any of the math functions like sine and cosine, you need to convert that to radians, so measured between 0 and 2 pi. So that's what we did here. And then we said that, well, now from an angle you can read off an x and y coordinate using cosine for x and sine for y. And the thing that we forgot is that for us, because this is computer graphics, the y coordinates are actually going the opposite way that we're thinking of. So I failed to negate this thing, and that's what I should have done. So now this is correct. And so now when you thrust, what happens is the vector that you're traveling on gets this little value dx added to it, and this little value dy added onto its y coordinate. And what does that do in the game? Well, I'm pushing the space bar, which causes this thrusting, and there you see. And if I hold it, then this thing goes crazy because it's increasing without bound. All right. And I cleaned up the code a little bit. So I added a couple of helper functions to my spaceship class that are just things that ask questions about the current state of the ship. Is it thrusting? Well, how do you know if it's thrusting? Well, if the user is holding down the space key, then it should be thrusting. Is it trying to turn counterclockwise? I haven't implemented that yet, but the way to test for that is if the user is holding down the left arrow key, then it should be turning counterclockwise. And is it trying to turn clockwise? Well, if the user is holding down the right arrow key, then it should try and do that. And so when you update the ship, you do the usual updates. So you change the angle because it's rotating. You change the position because it's traveling along some vector that's called travel. And then you check to see if you need to update either of those things. If you're thrusting, then you call that thrust function we just looked at. And if you're trying to turn left, meaning counterclockwise, you add 1 to the rate of rotation. And if you're trying to turn clockwise, then you subtract 1. All right. So that's good. And let's see if that's going to work for us. So there. I just held the left arrow down, and that got it turning counterclockwise. If I want to stop it, I can hold the right arrow, and now it stops. And it was really lucky that I actually got it to stop there. In general, it's hard to make it stop exactly. And now I can drive this thing around the screen, if I was any good at this. My guess is that the designers of the original asteroids realized that the physics weren't quite right, but also realized how hard it is to drive one of these things when the physics is right. And this is surprisingly difficult. Okay. So any questions so far? So another sort of little feature that I added just before class was in this draw on routine. I added a little section of code to check if it's thrusting, because I want you guys, because you can't see what my fingers are doing on the keyboard, to see what's happening. And in this case, if it's thrusting, then there's a small calculation that shows, just draws a red circle in the back of the ship. And this is just this is a bit of trigonometry. So basically, you find the center of the ship is self dot position, and then you walk backwards from there 40 pixels, and that happens to land on the back pixel of the back of the image. Any questions? Is there anything you would like me to do with this? Any direction you'd like me to proceed at this point? Yep. Have it what? Okay. So somebody wants me to make something that shoots. Okay, so let's think about all of the things we need. We're going to need a projectile. And let's make it simple, and it'll just be like a circle, so we don't have to download an image. But if you want to get fancy, you can download a missile image or something. Okay. So, and this will actually be a good lead-in. So let's say class, what do you want to call those projectiles? Projectiles? Projectile. So when you create a new projectile, meaning you shoot, what are the sort of parameters that matter? Yeah. Direction. Anything else? Yeah. Position. Yeah. So not just the direction, but the starting position and the starting direction. So I will say, well, rather than direction, we've been using, well, maybe not. I'll say self.travel is, let's say, 3 times direction. And self.position is the position. So the usual constructor, we just save this thing. And then we want to be able to do the things that game objects can do. We want to be able to update them. And so that is just self.position equals self.position at 0 plus travel at 0. So I think that's all that a projectile needs to do to update itself, is to move itself along. And it also needs to draw itself. So you give me a screen and I should draw this thing. And let me just copy some code from in here. I've already drawn circles. When I was doing the thrusting, so I might as well copy that. This will be a really easy one. Oh, we'll actually see something will come and bite us here, and we'll possibly, and we'll deal with it. Okay, and how big should these things be? Maybe of size 3, and they're red. Okay, so that's my projectile class. Just make sure we don't have any syntax errors. It's certainly not going to do anything exciting yet, because it's not even part of the game yet, but at least it compiles. Okay, so now I want to introduce this into the game. What do I need to do? I need to draw it, but I need some way for this to happen, right? I mean, when does a projectile get created? When the user pushes a button. So now the natural thing to do to get, some visible feedback here is to, or at least some way to progress, is to say, well, maybe we need a new button handler. And so that's pushing a button is an event. And in this case, at least the way I think of it is, it's a discrete event, meaning you push the button and one missile comes out. There's other ways. You might think, oh, this is a rapid fire thing, so as long as you hold the button, it keeps coming out. In this case, the way I'd like to set it up is you push the button once and one of these projectiles comes out of your thing. Okay, so here's our event loop. We have quit events, we have refresh events, and what was the name of Pygame key events? Key down. And what is a good what's a good key for firing? We're already using space for thrust. That would normally be the fire thing. Maybe a control key. There's left control and right control. Let's go with left control. So the left control key will be the fire button. Make sure that's working. I'm not seeing it. Maybe it doesn't like that key. So I'm a little concerned because this computer is set up to make the left control key show me the position of the mouse, because sometimes I can't find my mouse. It may be actually eating that event and preventing Pygame from taking it. So let's just pick a different key. What's that? Shift. Let's see. I'll guess at that one. Okay, good. Shift works. So that left control key doesn't work, but that's an issue of my system. Okay, so now we're capturing this thing. And that means we would like our ship to fire one of these missiles. So let's think about all of the things that need to happen now. So in general, you'll be able to shoot more than one of these things at a time. And who is responsible for taking care of all of this stuff? There's the ship, there's going to be some missiles, there's probably going to be some asteroids if we ever get there. My guess is it's the game should keep track of all these things. So in our game, well, we should have a list of projectiles. It's initially empty. And when someone fires, we'll say something like self.projectiles.append. We need some way of firing these things, so let's say fire. So the ship kind of knows about its direction, and it already has calculations in there for things like turning that direction into something useful. So let's pass it off onto the ship, who's going to create the projectile for us and return it, and then we'll add it to our list of projectiles. So we'll introduce this ship fire method. Let's do that. Okay, and so we need to do exactly the same calculation that we did for thrusting, because that tells us exactly which direction we're facing in. We don't need to multiply these things, the x and y, by 5. For a direction, we don't want to multiply them by anything. And so let's say what we're going to return is a projectile. We need to specify its position. For now, we'll try self.position, and we need to specify its direction, which is just dx and dy. All right. So we fire that thing, and let's make sure we see something. Okay, press shift. All right. So that list of projectiles now contains one projectile. And now it contains 2, and 3, and 4, and 5, and 5, and 6, and 7. So it seems to be creating these things, but I'm not seeing anything yet. Why am I not seeing anything yet? What's that? Now we got to draw the projectiles. So in our draw routine, well, now we've got a whole set of projectiles for P in self.projectiles. This is usually the easy part. We say P.draw on self.screen. Okay. Try that. Okay, pause not defined, so in the draw circle function or the draw on method, there's an undefined thing, and it's the usual mistake. Here we are. Pause. There is no pause, there is self.pause. Okay, so fire one, and there it is. You see it? It's that little red dot right in the center of my ship. Right? Because when I created the projectile, it had the same position as my ship. It has a direction of travel, but right now it's not traveling. Why is it not traveling? In fact, I can create a whole bunch of them, and I'm not seeing anything different. What's missing? So I created this list of projectiles. I seem to be adding to it correctly. They're drawing themselves, but they're not moving. And why are they not moving? Well, I've given them a vector to move along. The thing is, the game never updated them. Right? So if you look at all of the game objects that we always do, there's typically this update method which adjusts positions and things, and then there's this draw on method. I've been calling the draw on method, that's why the thing appears, but I've never called the update method. So typical thing when you do something like this is, here in the draw method, you draw the ship on the screen, or draw the projectile on the screen, and here you say p.update. Okay, and now we see this, we get bit by this annoying thing that I mentioned was going to happen. So Pygame is complaining, and it's saying, oh, Pygame, draw a circle screen, whatever, integer argument expected, got float. It annoyingly didn't tell me what's the integer argument that it expected, but actually it's this position. So internally, I'm using, this position is is some floating point number, and when Pygame draws shapes like circles and things, or at least for circles, it wants the center of the circle to be integer coordinates. So we have a slightly annoying thing that we need to deal with, which looks like this. So this is just a list comprehension that takes all the elements in position. There's only 2 of them, so I could have just done it, written them explicitly, and converts each one to an int and gives me a list of length 2, and that I should be able to use as the position for the circle. Okay. Those seem to be going off in the wrong direction. Why is that? Well, that's because we made some calculation error, and let's see what that error is. It's right there. I didn't negate the y coordinate like I did down here. Let's check. Now I have projectiles. And I think if I do it just right, I may even be able to get them to travel backwards in this following way. Get a little speed going. Again, well, no, actually, this is not accurate. So again, there's a physics issue here. If I launch a projectile and I'm traveling backwards, maybe its speed should take off relative to my speed. We can fix that if we want, or ignore it for now. But I mean, right now I've got some kind of working projectiles. They're a bit slow. I might want to speed them up by saying when you update, maybe instead of 3 times direction, let's do 10 times. Set the travel to be 10 times direction. So, nope. Of course. Okay, that's better. So now they take off out of your ship at a speed of about 10 pixels per frame. Okay. Any issues there? Anything that we could clean up or do better? I mean, one thing that's not so cute is the projectiles come out the top of the ship, but instead of the very, very front. We could improve the code a little bit to set the position a little more carefully to be right at the front of the ship, like I did for the thrusting. Or we can cheat and hide that fact by saying that when we draw things, first we'll draw the projectiles, then we'll draw the ship. So if our ship is sitting on top of a projectile, like happens right at the beginning, you won't see it. So you won't see it until it pops out the front. Okay. Okay, what next? I've got a ship that I can fly, it can launch projectiles. There anyone see a potential issue with the projectiles? Yeah.
You're going too fast across the screen and you run into one of your projectiles.
Okay, so you want to be killed by your own friendly fire? That's allowed? Okay. All right, so then we should, that means that all of this stuff is under the control of the game. And when would you want to check for this thing? Well, basically every frame you want to check to see if you ran into one of your projectiles. So that's going to look something like, we'll do something like a really lazy thing would be we check the distance from P to the ship's position. And if that's small enough, I don't know, maybe 25 pixels, then something bad should happen. So for that we need a distance function. We've done one of those before, but I'll quickly do one now. So there's a concise and difficult to read piece of code. I create an array that contains the square of the differences between all the coordinates. I sum that up, and then I take the square root. That gives me the distance. And I forgot one closing parenthesis. So I have no idea now how I'm going to test this, because I can't fly this ship well enough to get in front of one of my own projectiles. But we can do something to test it that will also point out maybe a slight issue, something that we didn't think of.
Could you make your missiles go on to the other side of the screen like the ship does, and then you can get it to hit the back end?
Yep. And that points out something, another sort of issue, and that'll become apparent very quickly. So when we update everything, our missiles, maybe we should do the same sort of thing that we did with our ship. So here we updated the ship, and then we did this modular arithmetic on the coordinates of the ship to make it wrap around from the left side to the right side, or the top to the bottom. Well, we can do the same thing for the projectiles, for each projectile. So that looks like P's position is its position. Uh-oh. Here it comes. Boom. And eventually they're all going to hit me. Okay, so the collision detection is working as well as it's programmed. But you see the sort of problem that's coming up now? Missiles aren't disappearing after they hit you, but also the missiles last forever. I mean, they last until they hit something. Maybe that's okay. I don't know. But it gets, it depends on the game, I guess. It depends on how you want to play this, how hard you want to make this game. But, all right. So missiles aren't disappearing after they hit you. That's not too bad. That we can just say. Let's do it. Let's do it this way. Okay. All right. So instead of saying boom, we will make a set of exploded missiles. So each time we detect a collision, we add that missile or that projectile to the set. And then once we've processed everything, we say that self.projectiles equals P for P in self.projectiles if P is not in the set of exploders. Okay. So while we do this, we collect up this set of missiles that are exploding. Once we're done iterating over all the missiles, we iterate over them again, and we just don't keep any of the ones that just exploded. See if I can. Uh-oh, that was a mistake. I'll never recover from that. Let me just test. Oh, you know what's happening? The missiles are exploding immediately because they start out on top of my ship. So that means we can't be lazy about where missiles start. We'll need to be a little bit smarter than that. So when I say fire, the position should be a little bit ahead of my ship. Okay, now they're living. It didn't quite hit me, but no. Now as they run into me, they do indeed die. And if I'm keeping track of damage or something, now would be the time to do it. All right. Anything else we should add to this game? Yep. Make a target to shoot. Okay. So maybe we should make an asteroid. And let's do that. Well, okay, let's do it the most obvious way. The game's called Asteroids, so we should have asteroids. And as soon as we start to do that, we'll see, well, maybe there's some... So what's an asteroid like? Well, an asteroid is like a ship. It has a direction of travel, and it even has a direction of rotation. In the asteroids game, these things spin around. And it has a position and, I guess, some initial angle. So in that sense, an asteroid looks just like a ship. And let's actually put these two side by side just so we can keep that idea. And it looks like, let's see if I've got an asteroid picture. Yeah, sure, there's an asteroid. Asteroid small. Okay. So it's asteroid small.png. And we can copy most of this code. How do you update an asteroid? Well, it's exactly the same way that you update a ship, right? Its angle changes based on its rotation, and its position changes based on its travel. And how do you draw an asteroid? You rotate it so that it's rotated the right way. You draw it at some particular position, and there's none of this thrusting business for asteroids. So that should be our asteroid class, entirely done. And now we need to create these things. So when do we create asteroids? Seems like random times kind of work. So let's say every time we update. Let's just check that everything compiles. Nope. Forgot his colon. There. And let's imagine that every time we update, we think about possibly creating an asteroid. So here's our game. 30 times a second, we call this update thing. That updates the ship, it updates the projectiles. Well, we probably want a list of asteroids. Let's make that. When we update, we will want to go through all of those things. Update each asteroid, and then also do the modular arithmetic on the asteroid's position so that it wraps around. All right. Good. And when we draw, we should draw every asteroid. So far, so good. And now we just need a time to create these asteroids. Let's just to test our code so far, let's just create one right at the beginning and see how it looks. Okay, and an asteroid takes the following arguments. They were position, travel, and rotation. Position, we might as well set to 0, 0, just for testing. Travel is, I don't know, let's set it on a course of 5, 5. And a rotation, we'll set it rotating counterclockwise. Asteroid is not defined because it was called asteroid with a capital A. Okay. So it tells me that asteroid object takes no parameters. Ah, there it is. That would have been difficult to spot. Okay, so I created some asteroid, but it didn't go anywhere. Why? We have some debugging to do. What's that? Aha, it's for A and self.asteroids. Cut and paste error. Asteroid has no attribute named ship image, of course. That's another cut and paste error. Because its image is called asteroid image. Okay, there it is. You should use transparent images for these. A couple of things you can see is, certainly when the ship and the asteroid get close together, you see the box around it. You also see that the asteroid itself is not quite, its background is not quite white, so it doesn't match this thing. So we should get some transparent images. One thing that this highlights actually is, do you see what's happening to the box around the asteroid? Unclear if you can see it in that monitor. Gets bigger and smaller. And why is that?
Trying to fit in the original rectangle that you defined.
Yeah. So many of you may have encountered this in one of the assignments when you try and make things that roll and you start doing rotations. Then it's really important that the coordinate that you care about is the center of the image, ultimately. Otherwise, you get things that roll and they kind of lump around, jump up and down. Okay, so we can't fix that without finding better images that have transparency in them. These ones apparently don't. But this asteroid class seems to be working, and now we can start creating these things. So I just created a boring one initially, just to test it. But what I would rather do is, after all of the other updating, so maybe once every 3 seconds or so, that's probably way too fast, we'll introduce another asteroid. And So introducing an asteroid, actually, a new one, there's a lot of decisions to make, like where should it go, what direction should it go in, and what direction should it spin in. The spinning is not really critical to gameplay, but it's nice to have them not all spinning the same way. So one thing that I sort of easy to do is to say that the rotation is a random number between -5 and 5. That's fine. But what about the position? Where should an asteroid appear? Could come from any direction. It should somehow appear off the screen, which we don't really have a good notion of because immediately the coordinates get modded on the screen. So maybe some point on the boundary. So I might do something like, say, the position will be let's put it on the top of the screen, and let's put it anywhere between 0 and the width. And the direction of travel, that's kind of another easy one. Well, let's break that up into two things. Something between 0 and 5 is the speed, and the direction will be a random angle, and that means that the travel should be, take the speed and you multiply it by the cosine of the angle. That gives you the x travel, and then you take the speed and you multiply it by the sine of the angle. It gives you the y travel. And now we're good. That's our position. That's our travel, and that's our rotation. So random number generator is really your friend in making these kinds of games. Random.random times self.width. There should be no dot there. I need to call this as a function. Where is this happening? Should I really not use random yet in this thing? There you go. Okay, so if we wait for a bit, there we go. Let's get away from that one. All right. So what's left? Now it's a matter of doing collision detection, cleaning up the graphics, and most of that can be done with better images. So let's get something we can at least do a few steps on. The sort of natural thing now is collision detection. I already have it that I can shoot myself with my own missiles. More interesting is shooting an asteroid. And I know exactly where to do that now. In the update loop, this is me looking for look for collisions between projectiles and the ship. We should also look for collisions between the projectiles and asteroids. So there we walk through the list of asteroids. So if an asteroid and a projectile collide, both the asteroid and the projectile should explode. And so I need to get rid of the exploding projectiles, and I need to get rid of the exploding asteroids. All right, let's see if I can actually shoot something here. There we go. And the nice thing about this is I just have to spray the whole board with projectiles, and eventually I'll kill every asteroid. So what next? Any crazy feature you want? I mean, the natural things for gameplay would be some kind of health for the ship, whether it's just immediate death if you have a collision, which then makes it so that you maybe don't want to fill the entire board with projectiles, because then you're just shooting yourself sometimes. Any suggestions? Any technical questions? Yep. Maybe limit the number of missiles? Yeah, that would be easy. So to limit the number of missiles, for that we need to look at where the missiles are fired. And that's when you press this left shift key. And if you want to limit the number of missiles, then you would say something like, if the current list of missiles or projectiles, the length of that is less than or equal to some number, then you're allowed to fire a new one. Otherwise, you might play some sound here, like clicking sound or something that says, to indicate to the user that they, although they asked to fire a missile, something, it didn't work. And so I need to define max projectiles. So that could be something like maybe 10 at most. And now if I keep trying to shoot, at some point it stops working. Okay. Anything else? I mean, you're limited really only by your imagination here, and you know, the files you're willing to download. I don't know, I might put in, make this a really tough game and say, we're already checking if our ship is hit, so let's let's give our game a couple of states, which could be there's a playing state, there's a game over state, and we'll start out in the playing state. So that's right here. And we'll wrap this whole thing maybe we'll make it a bit easier. All right. So if you're in the playing state, then you should update all of the action and draw yourself. But if you're not in the playing state, meaning you're in the game over state, then maybe something else happens. So let's see how close we are to... Uh-oh. Okay. And let me shoot myself to see if I can get into the game over state. No. Oh, I never transitioned into the game over state. That should happen here. Collisions between projectiles and ship. If this happens, self.state equals game over. And another, so that will test. And then we have one last kind of collision to test. Okay, so that just transitioned into the game over state because I shot myself. In this case, it's kind of a boring game over state. What I would do to add to this is maybe in the draw routine, I would put that in there. For now, I won't do it. And the last sort of piece of the puzzle, collisions between the projectiles and the ship, collisions between projectiles and asteroids, and there's collisions between asteroids and the ship. Okay, and now we just wait for an asteroid to run into us. Anybody see what just went wrong there? Where do you see that? Oh, this one, there it is, of course. There we go. Wait for an asteroid to show up and then fly into it. Game over. Okay. So, there's the basic gameplay of this thing. If you want, you can, instead of immediate game over, you can add lives, include score, whatever you want, add noises, add sounds, all of those things. Okay. So, are you guys hopeful about getting your games finished? Are they finished already? No. Are you hopeful?
Hopeful is a good word for it.
Okay. All right. So don't stress too much. Remember, the game assignment is one out of many assignments. It's worth the same amount as the other ones. Some people really run with it. Some people don't get so excited about it. But in any case, that one assignment is not going to kill you, and it's not going to make you. So, good luck.